Hello everyone, I'm Toby Lee from Carnegie Mellon. Today I'm going to present our work on KITE, a tool for building conversational bots from mobile apps. This is a joint work with Oriana Riva from Microsoft Research when I was an intern there. Recently, conversational bots are getting increasingly popular and are coming to all kinds of devices. They can be divided into two categories. There are social chit-chat bots designed for maintaining unstructured casual conversations, often for entertainment purpose. There are also task-oriented bots whose main purpose is to help users complete a task. State-of-the-art chit-chat bots are usually trained on large conversational corpus in an end-to-end fashion. In this paper, we focus on task-oriented bots. Most task-oriented bots are built using the slot filling approach, where the conversation is structured, unlike the end-to-end corpus-based approach used in the social chit-chat bots. The structures in slot filling approach can ensure all the constraints and dependencies in the task. The conversational goal of the bot is to obtain values for all the needed slots for the intent through conversations. Here we listed some key components in the slot filling approach. The goal of our tool, KITE, is to reducing developer efforts for building slot filling bots by automatically extracting those components from existing mobile apps. Before moving forward, I want to first explain the slot filling process. Use a simple travel booking bot as an example. Suppose we have a bot whose supported intents are as follows. And the user says, I want to book a flight for 2 to Munich. An intent recognizer will first recognize the intent as book flight, which has 4 slots. And then an entity extractor can extract the arrival city and the person count from what the user said in the routines and fill them into the corresponding slots. There are 2 more slots, departure city and date, whose values need to be provided for this intent. So the bot will use developer-defined prompts for these 2 slots to ask user questions. And then the bot needs to decide which next intent to go to. It will ask user a question and detects the next intent is book hotel. This is a simplified example where we ignore many details, but it should give you an idea of how the slot filling approach works. There are many popular tools for building slot filling bots, such as Google Dialogflow, With.ai by Facebook, Microsoft Bot Framework, and Amazon Lex. These tools require significant developer efforts, where developers have to manually specify intents, slots, constraints, and also provide prompt questions, sample utterances, and slot values before they can connect the bot to backend. These screenshots show an example interface of Google Dialogflow. We can see that the developer will have to manually specify the intents, slots, and prompt questions, and provide a list of possible slot values. If you look at here, the developer also needs to provide a list of sample utterances, such as I want a cappuccino to go, or do you have iced latte, with entity tags for training the intent recognizer and the entity extractor. In this work, our goal is to reduce developer efforts by automatically bootstrapping control structures and conversational interfaces in the boot development process. To achieve this, we designed and implemented a system named KITE. We have 3 major design goals for KITE: high task coverage, good app flexibility, and a low learning barrier. Nowadays, we have far more mobile apps than conversational bots available. There are many businesses and services who have mobile apps but not bots. Our key goal is to leverage existing apps for bootstrapping templates for conversational bots. Our high-level intuition is that the graphical interface of mobile apps encapsulates the task logic needed for building a bot, where we can identify intents and slots from these interaction traces. Let's take the OpenTable app as an example. Let's look at the user interactions of making a restaurant reservation using the app. In the first screen, the user needs to provide inputs on cuisine type, city, person count, and the time for searching for a restaurant. And in the second screen, the user will need to pick a time from all the restaurant's available time slots. And finally, the user needs to provide his personal information, such as first name, last name, and email. And from those, we can extract intents and slots from which we can build a bot. Now I will explain our approach by walking through the developer experience of KITE. On a high level, bootstrapping a bot using KITE can be divided into these 3 steps. The developer will first need to use our Android client to collect some traces of using a mobile app to complete a target task. For example, suppose the user is building a restaurant reservation bot. He will probably need to use traces from apps like OpenTable. For a simple task like this, it usually needs around 5 to 10 traces, depending on the complexity of the task. Then the user can import the traces through these web interfaces provided by the KITE web tool. From those app traces, the server side of KITE will automatically extract the task model and generate a conversational layer on top of the task model. Based on the extracted task model, the KITE web tool will show an interactive visualization of the intents. Like that's the interface. And we can see that the task model defines the control flow of the task by specifying the possible transitions between intents. All of those are extracted from the traces. And when the user click on one of the intent here, the bot developer can see all the slots contained in that intent. Each slot will contain possible values extracted from the apps, and also natural language prompts generated by KITE. Among all those prompt questions, the developer will need to choose the best one to use in the slot. For each of those prompt questions, the KITE will also generate sample user utterances for which can be used for training the natural language understanding model of the bot. The developer can also manually edit all those fields to improve the quality of the bot. Lastly, the KITE web interface features a live preview of the bot. In this interface, the developer can try out the current conversation flow and prompts so they can iteratively improve the quality of the bot. The approach we use in KITE brings some unique challenges. The GUI structures of different apps vary a lot. Traces collected are often also tangled, so it's hard to extract a task model in bot languages from apps. When generating the conversation layer, we also face a problem of the lack of domain-specific corpus, the lack of semantic context in our inputs from apps, and with the need to generate non-factorial questions in conversations. Let's look at the design and implementation of KITE and see how we address those challenges. This diagram illustrates the architecture of KITE from a high level. KITE will first extract the task model. This is a 3-step pipeline that includes trace collection, trace aggregation, and intent slot extraction. Let's look at the details on how KITE extracts a task model. For collecting a complete UI and usage trace from Android apps, KITE instruments those apps through the Android Accessibility API and also Android Application Framework. This method does not require any modification on the apps. After collecting and aggregating the traces, KITE will extract intents from them. We consider a transition from one activity to another to be an intent, because that's how most mobile apps are organized, where each activity represents one action the user can do. For example, for the search activity in OpenTable, it represents the action of search for a restaurant, which takes 4 slots: the type of restaurant, the location, the number of persons, and the time. In many apps, there are also sub-pages within an activity. Like here, we have reserve, menu, and reviews. Each represents an action, so we create an intent for those sub-pages as well. For each intent, KITE will extract the slots. This is actually challenging because app interfaces come in all kinds of layouts without a unified interface. So we developed a heuristic that can accurately extract slots from app interfaces. And then KITE will extract possible values for slots. Like for this slot, for number of people, we simply extract the possible values as 1 person, 2 people, 3 people, etc. After that, KITE will determine the name for each slot. Some UI element will contain developer-specified labels, such as first name, last name, and email here. For others, we perform entity extraction on those values. Like for those with time values, we just name this time. Once we extract the task model, KITE will generate question and answers for each intent and slot in order to support user conversation. It takes a hybrid rule-based and neural network approach. For slots with semantically meaningful developer-specified labels like this, we just use a simple syntactic rule to generate questions. Similarly, for those with semantic meaningful entity extraction results, we first identify the entity type and generate a question using simple syntactic rules. For slots with no meaningful label, no entity extraction results, or multiple entities, and for generating more natural sounding questions, we use a neural network-based sequence-to-sequence model. The inputs of the model are the slot values, the task domain, and the extracted entities from the slot values. The model will return top K results where the developer can choose the best one to use in the bot through the KITE web tool. We use the state-of-the-art transformer model for sequence transduction, which is an attention-based sequence-to-sequence neural network model. To prepare the data, we filter large general domain conversation corpus, such as Twitter conversational data, using keywords that are relevant to the domain. For example, when we build a coffee ordering bot, we use conversations that contain coffee-relevant keywords and conversations that involve Twitter handles of coffee shops. For the chosen prompt question, we generate a sample set of user utterances, so the developer doesn't have to manually come up with them for training the natural language understanding model of the bot. We perform 3 separate evaluations for KITE, each focused on a different aspect of the system. We first evaluate the accuracy of our extracted task models. We selected 25 popular apps from 12 task domains. 5 were used as a development set for us to train the parameters used in KITE, and the rest 20 were used for evaluation, where we run KITE on them without any modification. We calculated the precisions and recalls for the intents and slots generated in the task models. Here are the results. We can see KITE can generate pretty accurate task models. There are some false positives in slots because sometimes KITE would incorrectly count UI transition events as slots, but this can be easily fixed later by the developer in the web tool. We evaluated the appropriateness of generated questions. We used 3 independent readers to evaluate whether each question is appropriate. All slots in our test sets have at least one question that was considered appropriate by all readers. This is a more important metric than the really low precisions of the questions, because in a dialogue management system, each slot would only need to at least one good question. So we generate much more than we needed, and we expect the bot developer to choose the best question for each slot in the web tool. We also evaluated the relevance of generated answers. The results were mostly promising. For some domains like library, we get a lower relevance score for generated answers because we have a smaller domain-specific corpus, simply because there were less conversations about libraries on Twitter. But in the results, we can see that the domain-specific model still get higher relevance score than the multi-domain model, which suggests that our approach of filtering conversation corpus by domain is effective for generating more relevant answers. Lastly, we conduct a developer study to evaluate whether KITE is usable and useful. We recruited 10 software developers, including 3 professional bot developers. They were asked to use KITE to build a restaurant reservation bot from traces of OpenTable app. 10 out of 10 participants successfully built a bot, and they on average spent 21 minutes on the task. In general, we can see that our participants found our system easy to use and useful in the survey. One participant, who was a professional bot developer, commented that she spent a lot of time and effort at work to create test models for the bot, so the test model extraction in KITE can be very helpful for her job. Participants also noticed that conversation flows generated by KITE, while often correct, were also often unnatural and too lengthy, which results in extra cognitive load for users. This suggests the difference in the design principle between graphical interfaces and conversational interfaces. This naturally leads to the first direction of our future work. We want future versions of KITE to generate more natural conversations that better resemble natural human interactions. In this work, we also did not look at the fulfillment of tasks. For future work, We also plan to integrate with popular bot hosting platforms and support automatic construction of API calls for intent fulfillment. At last, we also plan to explore task execution through apps. We're looking at the possibility of executing the task through GUI, record and replay, or mobile app deep link when there's no API available. That brings us to the end of the talk. Thank you very much for your attention, and I'm happy to take questions now.